Welcome to my space weather update for the 28th of June 2022. And the news today is that the sunspots are back. First, let us take a look at the summary chart that I put on my Twitter channel this morning. The sunspot number 1 here, it has increased slightly since yesterday, is now at a level of 70. The KP index, which is a measure of how disturbed the magnetosphere of the Earth is, has dropped. It was up in the 4s and 5s yesterday. It's now down to 1s and 3s, even though the solar wind has increased to 520 kilometers per second. The solar X-rays measured by the GOES spacecraft have dropped now further to B2, which is an indication that the sun is still relatively quiet. The good news is that we have the Solar Dynamics Observatory data back. This is a composite image with the white light sunspot image in the middle here, and the background image is a set of coronal images mixed together. We can see on the sunspot image that there are 5 new regions that have appeared. Those are circled in white. We're about to lose region 3041 over the west limb today, so we could expect the sunspot number to possibly drop tomorrow. 3040 has actually developed a little bit in the last day and has got some extra spots. Last but no means least, yesterday we had 1 C flare. It was only a C1 flare, mind you, and we had 5 coronal mass ejections. This is my polychromatic image of the sun. You'll notice it's different from previous days because we've now included the SDO data, which is got a wider range of things to look at, plus also has much higher resolution. On the left we have the sunspot picture that I showed you before, and next to it the magnetogram taken by HMI for the equivalent time. And you can see that each of the sunspot groups have a significantly strong magnetic field associated with them. But there are also lots of magnetic field on the sun that don't have sunspots. We have H alpha from the National Solar Observatory next in the middle there. And you can see the prominences on the limb with those bright structures and also the dark filaments on the disk. You can see some of the same filaments in the transition region at about 50,000 degrees using the SDO AIA helium-2 304 channel. The prominences are visible on the limb as well, and this channel is particularly good for watching eruptions from the sun. The far right we have the low temperature corona, that's about 630,000 degrees Kelvin. That's from the iron 9 line at 171 angstroms. And you can see there's an awful lot of large scale structure here. These are magnetic loops joining these magnetic regions on the sun. And those interactions of those are the solar activity that we see. Bottom left we have something different. I have the AIA 1700 angstrom continuum channel, which shows these bright areas around sunspots. These are faculae, and these are what makes the sun warmer at solar maximum than at solar minimum. These bright areas are actually areas of hotter plasma than the general surface, and certainly a lot hotter than the cool and dark sunspots. Next to it we have the iron 12 channel at 193 angstroms. That's equivalent to about 1,000,000 degrees Kelvin. It's called the quiet corona, but if you look at a movie of it, it looks anything but quiet. It's moving all around. In the middle we have the iron 16 channel at 2.5 million degrees. This is for looking at the active regions, the sunspot regions, and seeing how they're interacting with one another and causing flares. The fourth image on the bottom row is the flare channel. This is iron 20 at 131 angstroms, has a characteristic temperature of about 10 million degrees. But as we haven't had any significant flares, it looks rather like some of the other channels we have around here. On the far right we have something different. This is the coronagraph images from the SOHO LASCO instrument. There's 2 of them, a C2 and a C3. The little white dot in the middle is the full size of the sun. So this is covering a huge field of view. Here is the X-ray signal from the GOES spacecraft. This is working in the 1 to 8 angstrom channel, the short channel. And this is where you can identify flares. You can see yesterday we had a single C flare, a low level C flare, a C1 flare, But since then we've had hardly anything, just a few high-level Bs, which means that the sun is still relatively quiet and not producing much activity. But let's take a look at the low temperature corona and just see how quiet it actually is when you look at it in the form of a movie. There is a large outflow of material from the sun called the solar wind. And at the moment, it's rather gusty. You can see the BZ component here is highly variable. It's oscillating between plus and minus polarity. Plus is the same direction as the Earth's magnetic field. Minus is the opposite direction. When you have a magnetic polarity that is minus, then it has the opportunity to interact with the Earth's magnetic field and cause geomagnetic storms. The density is about 2 particles per cubic centimeter. That's up slightly from yesterday, but really not particularly significant. The speed of the solar wind has increased to over 500 kilometers per second, shown here in yellow. Bottom in green, we have temperature. It's just over 100,000 degrees, which says it's basically a lower solar atmosphere origin for the solar wind. Models have been created of how the solar wind propagates through interplanetary space. The solar wind can be either accelerated in the interplanetary space or retarded by outflow. The top image shows that plasma density of the solar wind, and we've just been brushed with a small coronal mass ejection. You can just see it to the above and to the left of the Earth, which is the green dot on the right of the image. The bottom set of images, the plan view, shows us looking down on the top of the solar system, and we're about to be approached by a relatively high speed wind flow. You can see it's that spiral shape in yellow. This is turning anti-clockwise, by the way. So in the next day or so, the model claims that the solar wind speed is going to increase slightly. However, once again, the model shows that the strongest solar wind passed below us. Despite all of this, the magnetosphere has remained relatively quiet. You can see where it was disturbed a couple of days ago with the passage of a high-speed stream, but now we are in very, very quiet territory with the KP index oscillating between 1 and 3. To summarize, the sun is quiet at the moment, but that may not remain so. We have new spot groups that seem to be growing slowly. If they grow more quickly and start interacting, we could get some more flares. But at the moment, we're not producing any significant flares. We've had a few CMEs which have been observed, and by the way, I show a video of today's CMEs every evening on my Twitter channel, so you're welcome to take a look at that. So that's it for today. Thank you for watching the video, and until next time, stay safe and goodbye.